We are at 121 here, and we're down to the third module, which is hardware. And I should tell you, the Google Cloud credits are not working. We found out a few days ago we applied to them incorrectly, so they don't have the right domain name. So students can't get your free Google Cloud credits right now. We're working on getting replacements. Hopefully we'll have them soon. But Microsoft makes everything very difficult, so it may take a while. But be aware of that. You can still get a free trial from Google if you have a credit card, and that gives you like $200 or $300 of credit. But the $50 vouchers are not working. So be warned about that. A couple of students have noticed that, and it's absolutely true. Anyway, let's take a look at Module 3, which is here. Okay, so, all right, so we're going to talk about hard disk drives. In fact, I should be able to, that doesn't, there, that's better. All right, so SCSI is an old protocol to connect devices together. It used to be used on servers a lot, just a way to connect like a hard drive to a motherboard. And so there are still some computers that use it. And so if you're going to be a computer lab that handles seized devices from a crime scene, then you have to have a lot of old hardware to interact with all the random stuff people might have. If you're in a corporation, which is more common, then your corporation just standardizes on one brand of laptop and stuff, and all you need is the connectors that get to that. And you don't have company data on old junk, which is a bad idea anyway, because that stuff usually can't be updated and is fragile. But anyway, that's SCSI, I think. Looks like IDE to me. But anyway, all right, so here's IDE. And IDE is this one here with these long parallel rows of pins and the gap and more pins. That's the most common one up till maybe 5 years ago. This was really common. One thing about IDE, which is really great, is you could make a write blocker by just cutting one of these wires. One of these wires was the write wire, and one of them was the read wire, and you could just cut the write wire, and then the drive connection couldn't be changed. That is no longer true for modern hard drives, but it was true of IDE drives. That's why now we have to pay $300 and buy a write blocker, which is a whole computer. It's a complicated system, but back then it was easy. Now we have ATA. SATA is the modern technique. This is parallel ATA, and the modern interface is SATA. This is what almost everybody's using now. It looks like this, sort of like an L, some pins and a little knob here, a little indentation to make you put it in the right way. And this is how most hard drives and SSDs and everything are connected now, because it's faster, and therefore the most common one you'll find. All right, so once you have a hard drive and you figured out what kind of connector it has, now if you want to take the data from a hard drive, you want to clone the hard disk. Now, cloning means taking a hard drive, like a 500 gig hard drive, and taking another 500 gig hard drive and making it absolutely identical. Now, that is not something you do for forensic work normally. You do that for deployment at a company. What you do is you have a golden image of your operating system with the apps you need installed and with security products and everything, and then you make many identical hard drives and you just put them in the workstations. And then if somebody gets their workstation messed up somehow, you just replace the hard drive with a known clean hard drive and get on the road. You don't bother cleaning it or fixing the defects or anything. It's much more efficient. So that's mainly used as a way to distribute the operating system to the endpoints. So you don't normally do that for forensic work, because if I make an identical drive and the whole drive is 100% full of data, it's not very convenient. What's a lot better is to use a tool like FTK Imager that will take the data off one drive and create a file that's compressed on another drive, so the file will be smaller, and now I can copy the file and move it around and store it in the cloud and all that. That's usually what you want. So that's an image. It's not a clone, because it doesn't occupy exactly the same kind of physical hardware bit for bit, but it is an image, so it contains every bit from the original hard drive, but in a more convenient form, a file I can copy and rename, put in a folder and all that. And therefore, you cannot boot from an image. If you actually want to boot from an image, you have to go back and write it back to a hard drive, or a hard drive, a virtual hard drive for a virtual machine.
Images like maybe contain instructions, like Docker images, they contain like instructions how to do.
No, the image just contains every bit from the original thing, but then compressed. And typically, it'll add some metadata to it, like just some text, like the name of the date and time and the name of when it happened. It's just a more convenient way. So forensic people work for images because they want to access the data. People that are deploying Windows servers, they work from clones because they're just trying to make machines work. So you can buy cloning devices. It's very fast. You buy a device, it just has two connectors and a button, can copy this one to that one, and they're specialized and very fast and used a lot at companies. And this is one way to make a copy. It's just not usually the most convenient way for a forensic investigator to get the data they want. Then there's solid-state drives, which are, of course, very important now. Almost everything is switching to SSDs. These desktop machines might still be using spinning hard drives, but I think they're not. I think only the older machines have it anywhere because they use more power and they're slower. They're cheaper, but usually most people are willing to pay more for an SSD to get the higher performance, and all the thin laptops like my MacBook Air here and all the cell phones and everything are all using SSDs now for that reason, because they use less power. So, and SSDs have a variety of controllers and firmware. So if you have an older SSD or an off-brand SSD that's been installed without really the best driver, then it might actually work like a hard drive where it has sectors with leftover old data in them. But modern SSDs connected with the right firmware typically do not. They have a garbage collection process that cleans up the unused data within a few seconds. So in practice, there's almost no recovery of deleted files on SSDs. Unless you have a sort of a homemade system that's not really well configured. All right, they're more efficient, they're faster. All right, recovering deleted files is more challenging. That's one word for it. I remember I did this at DEF CON. I wrote a script so I could write to my SSD, and then I could show it dynamically, and as soon as you delete it, within 12 seconds, it's gone. So you could call that challenging. I think you might want a stronger word there. Basically, you're not going to get the delete.
That's why SSD doesn't need fragmentations.
That's right. Instead of defragmentation, it has garbage collection, which includes defragmentation. And the reason is, it is very slow to erase. So with a hard drive, you just erase and write on top, all in one move. But with an SSD, you have to first erase and then write, and the erasing is slow. So when it spends time rearranging the blocks to make a big block of empty space, and then erases it while you're not using it, so it's ready to save. If they didn't do garbage collection, supposedly they'd be much slower, although I've tried turning it off and I don't notice any performance hits. So I'm not sure if that's true, but it is true that they have garbage collection and they erase the stuff. So basically you don't get reused much from deleted data at all. Just a few fragments, not complete images or anything. This also means, by the way, that if you take the data off an SSD and calculate the hash, and then you do it again, you will not get the same hash because in the background it's erasing stuff. So it's sort of like a hard drive with read errors, which is rude, but that's another thing to realize. Let me just check for comments in the Twitch. A clone is a physical copy of the hard drive and a disk image is a digital copy. Yeah, that's right. A disk image is a file you created from a whole hard drive, which is a bunch of files and bootloaders and unused sectors and everything. You take all that and put it in a file. That's a disk image. Is there a max time that they can last? I do know they rate them for a certain amount of time. Like typically you expect hard drives to last a few years, and SSDs also, and there are articles that come by now and then saying a certain brand is dying faster than it should. There have been a lot of arguments about it. One big question is what temperature they should run at. Everybody used to cool their data centers down to like 60 degrees, and Google about 5 years ago realized it was perfectly fine to run your data center at 90 degrees, and that saves you a lot of power in cooling. So people argue about it a lot. Well, yeah, a clone is an exact copy of the disk and you could boot from it. An image, you can't boot from it. It contains all the data, but it's compressed, so the bootloader won't understand it. Good, I've seen the questions are good, going by. All right, so that's SSDs must erase data before a write can occur, and this process, trim, is the process that tells the SSD a file has been deleted. Now, if you have a rotating hard drive and you delete a file, the hard drive does not know that has happened. The hard drive does not understand the NTFS system. It doesn't know the difference between the master file table and the sectors. It just gets read and write commands, write some blocks here, write some data here, write some data here. So when you delete a file, it writes some data on the master file table, marking those blocks available, but the hard drive controller doesn't understand that at all. It just stores the data, it doesn't know what it means. So it doesn't even know what a deleted file is, which is why the deleted files just sit there. But SSDs must know, and that's what the trim protocol is. Trim is a function which tells the SSD, I just deleted this file, so you can clean up those sectors now. So the SSD driver is more sophisticated and is doing a lot of background work that spinning hard drives aren't. All right, that's the game here. The trim runs immediately after the recycle bin is emptied. Then it tells the SSD those files are gone, you can delete them. All right. Then there's RAM, which is real important these days. Like I mentioned, maybe 15 years ago, you would just image the hard drive and that was it. Now, the most interesting information is usually in RAM, especially for incident response, because you need to know like what malware is running right now, what processes, what network connections are going on right now. So you want the contents of RAM. So you don't pull it off and image it, of course, because when you pull it off, it would forget. You image it with a tool like FTK Imager on the box. A tool like Volatility. I'm not sure FTK Imager can do it, but Volatility can do it. Anyway, all right. Then there's RAIDs. This is a big issue. All the companies and cloud services have these complicated arrays of disks so that if one disk fails, they don't lose the data. There's extra redundant copies of the data distributed across the disk. So if a disk fails, the other disks have extra copies, and it will like turn on a light saying you need to replace this drive, and you have a big array of maybe 10 disks where 2 of them can fail and it'll still be okay. And sometimes 2 or 3 of those in parallel, all connected together in a complicated RAID array. So this means that it's really hard for a forensic analyst to analyze. If you wanted to image this stuff, you'd have to image all these drives, and then you'd have to somehow put it all together because the data is striped across all these drives in a pattern. And then you would have everybody's data that use this thing. And if it's something like Dropbox, that's, thousands of users, and you probably don't have a court order or probable cause for all of those thousands of users, so you're not allowed to collect all that data. That's why, in general, imaging this whole array is not a productive forensic activity for almost anybody. The only people that would do that are people who are trying to clone it to keep the drive up, not people who want to get the data. Well, all you do in this case is you get the active data. You go in and find the data that is associated with this one user now, and you don't try to collect deleted files. If you were to collect deleted files, you couldn't prove who owned them, and therefore you couldn't prove you had a legal right to examine them anyway. So unless you're, typically you don't even bother trying to do the kind of complete images of these things. You just get a copy of that user's data, like from the Dropbox image. Yeah?
How people are using Google file system?
Google file system?
Google
file system. I don't know about that. Okay, never heard of it.
It's like a distributed file system?
Another one. I know Microsoft has a distributed file system called ReFS, and there are others which attempt, instead of using RAIDs, they use sections of one hard drive and make extra copies of the data, so if a sector fails, they can continue to run. RAIDs, that happened about 8 years ago. Microsoft brought out ReFS, and they said RAIDs are now obsolete. See, one thing about RAIDs is you might have a whole bunch of 1 terabyte drives, then one of them has a read error, then you're supposed to throw the whole thing away and buy another 1 terabyte drive when like 99% of it is still good. That's why Microsoft said this is garbage. You should use a distributed file system like that, where just with 1 drive you put multiple copies, and that would be more cost effective and more logical in the future. But most people are still using RAIDs, I think. But there will come a time when they use something more complicated. Anyway, then there's removable memory devices, FireWire, and then it came out Thunderbolt, these things that can connect high-speed remote devices. I think FireWire is only on your older Macs. USB is big everywhere. USB flash drives. I haven't seen USB-C flash drives, but I guess they must exist. Usually, USB devices have FAT instead of NTFS because you want everyone to be able to read it on every machine. If you use NTFS and you write data onto a thumb drive, then it will be owned by the logged-in user on that machine. When you go to a different machine, it will not let you read them because you're no longer the authorized user, which is mostly an annoyance. So most people just use FAT or FAT32 on those drives. That problem with that is the maximum file size is often 2 gigabytes. And that's why when you use FTK Imager, it will offer to break the image into 2 gigabyte chunks so you can copy it onto a FAT volume, which is what's typically used to move things around. Then, of course, external hard drives are much more logical. You just connect your external hard drive to the computer, use it like a built-in hard drive. It's almost as fast. You can boot from these things. You can boot VMs from these things. You can store large amounts of data. This is the most common thing I think people use these days to move large amounts of data these days. Then, of course, there's all these multimedia cards. Multimedia cards, SD cards, which are very popular in cameras and other removable devices. Just like a USB stick, just another device you can store data on. And in principle, you can image them with forensic imaging software. I haven't done it to see what happens, but I think it's just like a hard drive, like a floppy. You copy all the bytes, And I guess these would still have deleted files on them. I haven't done it, I'm not sure, but I do not think they have garbage collection like an SSD. I think the deleted sectors are still sitting there, but I don't really know. Would be kind of fun to try sometime. All right, and then compact flash cards are more of the things, and Sony's memory sticks. There's just many of these cards. They all do essentially the same thing as a USB thumb drive. So if you want to read these things, you need to get a write blocker, is a good plan, just like a hard drive, and then you can make a forensically sound image of these things. And then there's optical discs. These also, I think, are going away. CDs, I don't know if anybody uses them anymore. Then there's DVDs, and then there's Blu-ray. And yet I don't hear much about them except for people trying to play movies at home. But you know, there's a time when you get your operating system on this and everything. So you can have CDs, you can burn your own CDs. I remember 20 years ago, everybody would burn their music on CDs. I don't know if anybody's still doing that. There's some that can be erased and rewritten. They're all read with a laser. They have a dye. Now the commercial CDs have been burned. Pits have been burned into the disc with a strong laser. So there's now dark spots and shiny spots, and that's the ones and zeros are coated with that. You read it with a laser. The rewritable ones use a dye where you can hit them with light and they will change color. And you can hit them with the light again and they'll change back. So you can write and rewrite. But the same thing, they're read the same way. You have a laser and the laser reads it as darker light as it goes around. And Blu-rays are more of the same. Blu-rays goes up to 25 gigs, up to 50 gigs, using a blue laser to read the disc. So they're just, you know, data is just more dense. Here's a comparison of the microscopic structure of these things. And then, of course, floppies. I don't know who's got these anymore, but anyway, you know, they used to have the big ones, 8 and 10 inch and 5 inch, 5 1/4, and then these things, 3.5.
How did they work?
What's that?
How did they work?
You have to have a drive, you put it in there, and then it's a magnetic platter, just like a magnetic hard drive. But it's on a flexible thing, so a Teflon-coated bar will bend it down to put it in contact with the head. So they rotate slower.
Just like a tape?
Yeah, just like a tape, in a flat form, more convenient to carry around. And the other thing is you can read them in a random order. Whereas a tape, you know, you might have to spin all the way to the other end to find the data. So they're random access, but yeah, basically the same technology as tape. Yeah. And then there used to be these zip disk things that are sort of bigger than floppies, but essentially the same thing. And then, of course, mag tapes. Mag tapes are still used for backups, not much of anything else, because mag tapes are cheap and fast. You can write a lot of data on them, so it's a good way to put a backup. The problem is, if you're trying to read data, your data might be at the other end of the tape, and then you'd have to wait like 5 minutes to spin down to the other end of the tape, and that's annoying. But that's really the only thing wrong with them. Of course, all these magnetic things also degrade with heat and time. So you really should keep them in a cool place. If you heat them up, that randomizes the atoms and erases the magnetism. So that's one issue. Now, CDs and DVDs were originally intended to last for like 300 years. They were supposed to be very resistant, but it turned out in practice they weren't that good. But the original design was to have all kinds of error correction in there so you could store your music forever. That was what they were advertised as. In practice, they weren't that good. Anyway, let's see if there's comments in the Twitch. How to equipment for a RAID array? I don't know. I haven't made them. Most people get hardware RAID arrays, and like I say, I think they're kind of going away. Microsoft claims their ReFS file system is better than a RAID array. I would probably go that way. ZFS is an open source one, yeah. Video games, they're talking to a student about that. And then back, okay, movies from Netflix, and yeah, burn them to keep a copy at home. Yep, that's right. Okay, good. And cassette tapes, okay, good. Lots of comments there, but I think none I need to answer. So let's try a Kahoot, which is module 3 right here. Okay. Any what? The ad forms? They won't tell me, but I can find out by looking online to see who got approved. I can do it later. You sent in a form, right? And did I send it in? Did I reply? Yeah, I think it takes them about a week to process it. You should have got an email from me when I forwarded it. Oh, okay, maybe I haven't done it yet. I have to look. Okay. I might be the holdup at this point.
Because I need to be registered by 7 September.
Oh, in 2 days?
These are regulations.
I don't know if that's going to happen. I can at least do my bit, but then it hands on to somebody else, and I don't know how slow they are. Well, I'm glad you told me. I can do it today. We'll see what good that does. All right, looks like we got everybody that's coming. All right, so what's the most common connector for hard drives? SATA is currently the most common. All right, what process makes a file containing all the data on your evidence hard drive? Okay, that's an image where you take every bit and put it in a file. A clone is where you make an identical hard drive of the same size. And copy and backup only copy the active data. They don't copy the unused sectors. So the forensic image is what it's called. All right, what storage device may erase the old data automatically with garbage collection? That's SSDs have that property. All right, which storage device is read with a laser? DVDs are optical. Okay. DVD, all right. DVD and SEGI. I'm not sure if my viewer will know who SEGI is, but maybe close enough to real name. Catch a real name. The other two are real names, which we'll be able to find. All right. Let me stop the recording.